Welcome to Procedural Modeling for Urban Design. This is the third video in the CGA-focused CityEngine Essential Skills training videos. In this video, we'll pick up where we left off in video 2. We'll improve our building model by using texturing and projections to display realistic materials. We'll also use a split operation to make windows and doors. And we'll look at how we can use reporting to make the building smart. In this example, we're looking at a report that gives us the gross floor area and construction building costs. We'll also learn some basic modeling concepts that will help us with the more advanced CGA operations. Let's start with an introduction to the concept of scope as it's used in modeling. In general, the word scope pertains to the extent of a thing, or how far does it reach. For example, the scope of this video are the subjects to be covered, and other modeling concepts are considered outside the scope of this video. In the world of 3D modeling, the scope is a rectangular 3D box that contains the full extent of the model within its bounds. It's also known as a bounding box, and it fits the model as tightly as possible. This box has its own XYZ coordinate system, which can be used for managing the model within. We'll be using the scope for texturing and for splitting floors, walls, and windows within our building facade. The model hierarchy window is a tool we can use to see the scope of each shape within the model. In the Windows menu on the toolbar, click the Show Model Hierarchy button, and you should see a blank grey canvas in the window that opens. Select just one building model. Now click the Inspect Model button. The model should now appear with a transparency, and use the Frame button to center it in the viewport if necessary. Open your rule, gis_building.cga, so that we can see how the scope changes for each new shape generated. Double-click the roof to see its scope. It's a 3D shape, so you'll see the X, Y, and Z axes represented by red, green, and blue lines. The entire bounding box is shown in yellow. Now select the wall by double-clicking it. It's a 2D shape, so you'll see an X and Y axes in red and green. There is no Z dimension for this shape, so no blue axis is shown. Open the Model Hierarchy tab in the inspector. Now click on the walls and roof of the model and observe the Model Hierarchy window. Notice how these shapes are highlighted in the Model Hierarchy window when you click them. This diagram is called a shape tree. It shows the flow of shapes through the rule, starting with the start rule on the left and ending with the final shapes on the right. Sometimes, especially with more complex rules, you'll want to see the intermediate shapes that are not shown in the final model. You can click on any of the rules in the shape tree to see their scope. Click on the start rule, building footprint, to see its scope. The start shape has a scope in the XZ plane with a 0 height Y dimension not shown, so you should see red and blue axes here. Look at the last line of the start rule where we use the comp command. The top selector sent the top shape to the roof rule. Click on the roof rule in the Model Hierarchy window. Note that the scope shown for the roof rule is for the shape entering the rule, not the shapes exiting the rule. So for the roof rule, you'll see the scope of the single top face of the previously extruded 3D volume. This one has an XY scope with green and red axes shown, and the blue Z axis is not shown. Also note that all faces generated from extrusions have an XY scope. Before proceeding, turn off the Inspect Model mode by toggling the button on the toolbar. Now that we've seen the basic idea of scope, let's use it while adding textures to our walls and roof. Texturing is the process of adding images onto the faces of a model. Scope allows you to project textures onto surfaces accurately for creating a photorealistic appearance. Let's start with the walls. Find the wall rule in your CGA code. First, we need to set up a projection. Imagine sitting outside of this house and shining a projector onto the wall. You would know which angle to shine the projector from, but CGA doesn't. Now open the help file and search for a setup projection. On the help page, copy the first of the 3 operations, the one with the 4 parameters, and paste it into the wall rule. If your wall rule has a final shape named Final Wall, remove that first and then paste in the code we just copied. The parameters must be replaced with values that we'll supply. The UV set parameter is one of 6 layers that control how the shape is displayed. Enter 0 here, since layer 0 corresponds to images. Axis selector is the direction of the projector. Recall that our walls have an XY scope and no Z dimension, so we'll use the scope.xy since the face has no Z dimension. Text width and text height are the real-world dimensions of your texture. For example, if you had taken a photo of a wood-paneled wall and your image shows a 1 meter square portion of that wall, then you would enter 1 and 1. The image will be tiled with that size, repeating until it fills a shape. Let's use 4 by 4. Your setup projection should look like this. Depending on which rule you started with, you may or may not have the color line. Then on the next line, type project UV and in parentheses 0. This applies the projection to the shape. Next, we use the texture operation to specify the image file to use. There are some example textures supplied with the project, so type this on the next line. Texture, open parentheses, double quote, and then the path to our wall texture file, double quote and close parentheses. Now save and generate the model. You should see a wood panel texture appear on the walls. I'm going to go ahead and remove the color line in my rule so we can see this more clearly. Also notice that the coloring based on the category attribute is still applied. Let's make a switch to toggle between colors and textures. In the rule, add a new attribute called display type with 2 options in the range annotation. Type @range, open parentheses, double quote, colors, double quote, comma, double quote, textures, double quote, close parentheses. On the next line, type attr, display type equals, double quote, textures, double quote. There are now 3 operations in the start rule, and we need to have conditional logic applied to the color operation only. Let's make that rule into 2 rules, one for the conditional coloring and one for the extrude and comp. Underneath the building footprint rule, put several lines of space. Then make a new rule called extrude mass. So type extrude mass, 2 dashes and a greater than sign. And then on the next line, type extrude, open parentheses, height, close parentheses. Then cut the comp operation from the building footprint rule and paste it under the extrude line in the extrude mass rule. Next, in the building footprint rule, make a case statement before the color operation. Type case, display type, 2 equal signs, double quote, colors, double quote, and a colon. Put the color operation on the next line and call the extrude mass rule. So replace extrude height with extrude mass. Then make an else case and call the extrude mass rule again. Then save and generate. So one case colors and the other case doesn't, but they both lead to the next rule called extrude mass. Now go to the wall rule and add a similar case structure using the new attribute. Before setup projection, type case, display type, 2 equal signs, double quote, textures, double quote, colon. Then put the setup projection operation on the next line and indent it. Also indent the texture and project UV operations. And after the texturing code, type else, colon, final wall, full stop. Now save and generate the model. In the inspector window, flip the display type attribute back and forth to watch it change. Then set it back to textures before we proceed. Next, we'll make a file picker to choose a wall texture. First, we need a new attribute. Scroll up to the attributes and type attr wall texture equals. Then leave this blank and scroll down to the wall rule and copy the string with the wall texture file. Scroll back up and paste that string as a default value for the wall texture attribute. Save and generate, And you'll find the new wall texture attribute is automatically given a file picker button in the inspector. Click it and you'll see the other wall textures. Double-click one of the other textures and see what happens to the models. The model should regenerate whenever an attribute is changed. But wait, why is the wall texture not changing? Try regenerating. Try picking a new texture. Still no change. Many times you will find your code is not doing what you think it should. This is where debugging comes in. In programming, a bug is something that causes a malfunction or unintended result. Now pause the video and see if you can work out where the bug is in the code. Okay, we're coming back from the pause. If you found the bug, then that's great. If not, then how would you go about debugging this? You might go straight to the code and just look and find it easily. But code can become much more complex than this example. You might try just talking it out first, explaining it to yourself in words. First, what is the problem? Our problem is that when we choose the wall texture, the model's texture doesn't update. When we use the file picker, we can see the value of the attribute changing. The texture is still being applied, but it's only showing the original texture. So by deduction, the texture in code must not be receiving the attribute value. Look at the texture in code. That's it. We left the original value in the texture operation. So replace the file name with the attribute wall texture. Save and generate, then try changing the texture. It is now bug-free. Let's finish the wall texturing by randomizing it. Go to the wall texture attribute and add this code. File random in front of the file name, open parentheses, and then close the parentheses. And in place of the 01, put a wildcard character. The wildcard character, when used with the file random function, allows a random file matching this pattern to be chosen. In place of the 01, the other two files with 02 and 03 can be chosen randomly. Save and generate. Then select several buildings and generate again. As we demonstrated with the random roofs in video 1, the Update Seed and Generate button can also be used to change the textures. Now that the wall's textures are working, let's move on to texturing the roofs. But first, let's improve the roof rule using our knowledge of scope. In our first version of this rule, we chose the roof type randomly. But you may have noticed there are some large buildings that have sloped roofs when a flat roof is more appropriate. To see this effect, zoom to the large building in the center of the scene and make sure the roof type attribute is set to hip or gable. Orbit around the building and see how the roof is many stories tall. In reality, that building has a flat roof. Leave this building centered so that we can see the effect of our next change. Change the default value for the roof type attribute as follows. Type case scope.sx greater than 30, a double pipe symbol, scope.sy greater than 30, colon, double quote, flat, double quote. And then on another line, type case p open parentheses 0.5, close parentheses, colon, quote, gable, quote. And then on the next line, type else, colon, double quote, hip, double quote. This first line means if either the length or width is greater than 30 meters, then use the flat roof type. This case uses the probability functions shortened to p, which returns a random true-false value depending on the percent frequency specified. And for the else case, we're using the hip roof type. Save the rule and select the building in the viewport. And then open the inspector window and right-click in the roof attribute and choose Reset User Attributes. This sets the roof type back to the default value, and you should see the roof become flat due to its size. Now zoom back to wherever you are working, or stay here if you like. Now let's further clean up the roof rule. Move the roof hip code into its own rule, like the other two. Cut the code type the new rule named hip roof and make this rule using the code you just cut. Now in the second roof type case, type hip roof. We are ready to texture the roofs, and we'll start with the code we already wrote for the walls. And to make this a little bit easier, I'm changing from the default layout to an editing-friendly layout. First, copy the wall texture attribute, paste it on the line beneath, and change the name in the file path as follows. Change the attribute name to sloped roof texture, and change the path from walls to sloped roof. And use a wildcard character for the entire file name, since they do not fit into any naming pattern. Then copy and paste that attribute to use for the flat roof textures. Change the attribute name to flat roof texture and change the path from sloped roofs to flat roofs. Now we need to reuse the code from the wall rule since it fits the same logic. Go to the wall rule and insert several lines of space beneath it. Then as the first line of the wall rule, type texture, open parentheses, quotation marks, wall, quotation marks, close parentheses. This is a call to a new rule that will use the old code from the wall rule. Go to the line above the old wall code and make a new rule with a parameter called which face. Texture, open parentheses, which face with a lower w and an uppercase F, close parentheses, and the new rule sign. At this point, we have only made a structural change to set up for more textures. Saving and generating will not produce any changes. We must use the input parameter which face for further case logic, which is nested inside the first display type case. Before the texturing code, type case which face, double equal sign, quotation mark, wall, quotation mark, colon, and indent your texturing code by selecting and hitting the tab key. Then on the next line, type case, which face, equals, double quotes, sloped roof, double quotes, colon. Then copy and paste this line directly beneath and change sloped roof to flat roof. Change final wall to final shape in the outer case, since this rule now handles more than walls. And finally, we need to add an else case to the inner case structure. In the else case, type final shape. At this point, you should still see compiler errors, since we have two cases without code. Now copy the 3 lines of wall texturing code and paste them into the empty space under sloped roof. In the texture operation, change wall texture to sloped roof texture to match that attribute. Now copy that code into the next case and change sloped roof texture to flat roof texture. Right above that code, beneath which face equals flat roof, type this comment. Our flat roof texture needs to be stretched across the entire roof. What this means is that we need to adjust the tiling of our projection. Rather than using a 4-meter square tile, we'll use the size of the scope for our projection. In the setup projection operation, replace the first 4 with scope.sx and the next with scope.sy. Recall that we use scope.sx and scope.sy for deciding which roofs should be flat, and now we're using it as the exact size of our texture. Now that we have a general purpose texturing rule, we need to send the roof shapes to it. Find the hip roof rule, use the comp F operation to send the different faces to the correct texturing code. Type comp open parentheses F close parentheses, open curly braces, then aslant, which selects the sloped roof faces, then colon, then send the sloped faces to the texture rule, with the which face parameter set to sloped roof and close the braces. If you'd like to see the texture on the hip roofs, save and generate. If you don't see a hip roof, just change a model using the inspector attributes. Now copy the comp F operation into the gable roof rule. Save and generate, and then find a building model with a gable roof, or change the roof type to gable in the inspector window. Notice it is missing the vertical wall beneath the gable. This is because the comp operation will drop any faces that are not selected. So modify the comp by adding the side selector and sending the side faces to be textured as walls. To do this, add a pipe before the closing brace, type a side colon, and call the texture rule with the parameter wall. Save and generate, and the side wall should reappear with the wall texture. Now for the flat roofs. In the inspector window, change the roof type to flat. Copy and paste that same comp operation into the bottom of the flat roof rule, and change the aslant selector to top. Then change sloped roof to flat roof. Save and generate, and the flat roof should have a texture that stretches across the roof. If you are not seeing any flat roofs, select some buildings and change the roof type to flat in the inspector and verify that it's working. If not, then step through the last few minutes of the video and make sure all of the changes were made. When you are ready, reset the user attributes in the inspector to get the random roofs back. Now that we have a textured building, let's add floors, windows, and doors. For this, we'll learn a very useful CGA operation called split. Splitting, like texturing, requires knowledge of the scope of the current shape. We'll be splitting in both the X and Y dimensions since our wall shapes have an XY scope. Try using the Inspect Model mode to verify this. Select a single building, toggle Inspect Model mode, double-click the wall, and see that the wall has red and green axes which correspond to the X and Y dimensions. Now turn off Inspect Model mode. First, we will split in the Y direction to show floors. For this, we need to create new attributes for the floor count and the floor height. Scroll up to the height attribute, and beneath it add a new attribute called floor count with a range of 1 to 3 and a default of 3 floors. Then add another new attribute called floor height with a range of 3 to 5 meters and a default of 4. Think about these two new attributes and how they might affect the height of the building. The height attribute is currently driving the extrusion of the walls up to the roof, but now our two new attributes will drive the extrusion height. Delete the original height attribute and its range annotation. Now you will see a compile error. Scroll down, find the error, and hover over it. It says no such function height because we just deleted that attribute. So in the extrude operation, replace height with floor count times floor height and use the asterisk for the multiply symbol. Save and generate, then try changing the values of the floor count and floor height, seeing how the models react. When you are done, reset your attribute changes to the default rule values by right-clicking in the inspector and choosing Reset User Attributes. To show the floors, we'll split the wall shapes, so find the wall rule. The wall shape is immediately sent to the texture rule, so we have to decide, should we split the wall before or after texturing it? The answer is to split the wall after texturing. This is so that all of the faces have a continuous projection, set up in one place for all of the wall faces. If we want to split after the walls are textured, then find the line that applies the textures, and send those textured faces to a new rule called Split Walls. Now scroll to the bottom of the rule, hold down the hashtag key to make a continuous comment mark like this. This has no function other than to give a visual clue that this is a new section of code. Now hold down the Enter key to make some more room to work. Start the new rule. Type split walls and the new rule sign. Add this split operation as the first line of the rule. Split the extruded shape in the direction of the y-axis by the distance of floor height and send that shape to a rule called floor height wall. Save and generate, and see that only the first floor is showing. The split operation must be told to repeat the split until the shape runs out. Do this by adding an asterisk after the curly braces. Save and generate, and now all of the floors are seen when the model is selected. If you don't have wireframe mode active, then toggle it in the gear-shaped icon at the top of the viewport. We have not made the floor height wall rule yet, so you should see a yellow warning icon on the split operation. Make that rule now and use it to color each shape a random color, just for testing. So type floor height wall, the new rule sign, color, open parentheses, rand, 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 close parentheses. Save and generate to see this effect. This works for random coloring because the rand function returns a random value between 0 and 1 if no range is specified. Using random colors is an easy way for testing splits because it shows each shape differently. Next, let's use non-random colors to tell us more about each wall shape. If we're going to put doors on these walls, then we'll need to know which floor is on the ground level. Fortunately, the CGA split operation assigns an index to each shape resulting from a split. It's stored in a built-in attribute called split.index along with the total of the split shapes, which is called split.total. Note that this is a zero-based index, meaning that the ground floor is at index 0. Replace the random color code as follows. If the split index is equal to 0, then go to ground wall rule, or else go to the window wall rule since the upper walls will all have windows. Then make those rules to color the ground rules green and the upper walls red. Type ground wall and the new rule sign, and then on another line type color, open parentheses, 0, 1, 0, close parentheses. And then make the new rule window wall, add the new rule sign, and on another line type color, open parentheses, 1, 0, 0, close parentheses. Now save and generate. We now have conditional logic to handle the ground floor separately from the upper floors. At this point, check any of the buildings with a gable or flat roof. Notice the highest wall, the wall created by the roof rule, is being colored as if it was the first floor. These faces are being sent to the same rule that textures the walls and then to the ground wall rule. Let's fix this by sending them to a wall texture case that will not be split. Scroll up to the texture rule. Copy this part of the wall texturing code, the 4 lines excluding split walls. Paste this as a new case right before the copied code. Then change only the which face parameter value to be roof wall. Now find the 2 roof rules that are using the side selectors in their comp operations, gable roof and flat roof. In both rules change side texture wall to side texture roof wall. To summarize, we have made a new case in the texture rule that uses the same texture code as wall does, but skips the splitting code. Save and generate, and the roof wall shape should still be textured but no longer colored as a ground floor. At this point, we can differentiate the ground floor from the upper floors and the roof wall. One more step before making windows and doors. Ask yourself, are we planning on having doors on every wall of the ground floor? Probably not. So far, we have used split.index to tell the floors apart, and now we will use comp.index to tell which walls have doors. Since the walls originated from a comp F operation, they still have indexes from that comp which are zero-based, just like split.index. Let's keep things simple and just place a door in the first wall. In the ground wall rule, replace the color operation with this case structure. Case comp.index double equal sign for equality 0 colon, and on the next line type door wall, and on the next line an else case, and on another line type window wall. The new rule door wall will have a warning flag, so make that rule now. Type door wall, the new rule sign, and on another line type color, open parentheses, 0, 1, 0, close parentheses. Save and generate, and now only the first wall is painted green. If you remember from video 2, we can set which edge of the shape is the first edge. If your green wall is not facing the street, try setting the first edge and placing the front door where it should be. You may need to double-click or triple-click the edges, then right-click and choose to set first edge. Or from the Shapes drop-down menu, select Compute First Street Edges. And now we can make our doors and windows. First, find the door wall rule and we'll split out a door. Replace the coloring code with this. Split in the X dimension, open curly braces, send approximately 1 meter to a final shape named X. The tilde means approximate and this shape will compress or expand to fill the pattern. Exactly 1.2 meters goes to a new rule called door split Y. Approximately 0.5 meters is the final shape. Exactly 1.2 meters for a window, another new rule, window split Y. Approximately 2 meters is a final shape. And remember to close the curly braces. Now let's finish the door rules. Make a new door rule called door split Y, and we'll split it in the Y direction. Open the curly braces. Exactly 3 meters is sent to a new door rule, add a pipe, and the rest is a final shape. Then close the curly braces. Now make the new rule door and add the new rule sign. And for now, just color it black. Color 0, 0, 0. Now save and generate to see the door. Now repeat that pattern for the window rules. Add a new rule called window split Y. Again, splitting in the Y direction. Relative 1/3 will go to a final shape called X and make a pipe symbol. Relative 1/3 will go to a new rule window, add another pipe symbol, and relative 1/3 will go to a final shape called X. The apostrophe or single quote means relative to the current scope. Since our floor height is 4, that means that 1 1/3 meters is going to each new shape. Now add the window rule. Type window, the new rule sign, and let's color it black like the door. Now save and generate and the window appears. Let's jump back to the red walls. These are coming from the rule window wall. Go to the rule and replace the color operation as follows. Split in the X direction. Exactly a ½ meter goes to a final shape on the corner. Approximately 1 meter goes to a new rule window pattern. And ½ meter to the other corner. The new window pattern can have many patterns of windows. Make it with these samples. Type window pattern, then the new rule sign, then 50% colon will be split in the X direction, and approximately 1.2 meters will go to the window split Y rule, and then after a pipe, approximately 1.2 meters will go to the same rule window split Y, And then again, after a pipe, approximately 0.5 meters will go to a final shape called X. And put a full stop after the X. Follow with an asterisk so this pattern repeats over the entire wall. Then for the next case, let's make it 25%. Again, split in the X direction, and approximately 1.2 meters will go to the rule window split Y. And after a pipe, approximately 1 meter to the final rule X. And again, add the asterisk to make sure the pattern repeats across the entire shape. Then add an else case, and once again split in the X direction, and send approximately 2.4 meters to the window split Y rule. Then send approximately 1/4 meter to the final shape, and add the asterisk to repeat again. The window pattern rule has 3 cases that randomly assign 3 window patterns. You can also expand this rule with any number of patterns of your own design. Just make sure the compiler has no errors before continuing. Now save and generate, and we'll see the final building form. The windows and doors are kind of drab looking, so let's add a trim rule. Type trim and the new rule sign. Remove the wall texture by setting texture to an empty string. Then offset inwards by 0.1 meters. An inward offset is done using a negative number. Then use comp to color the inside black and the trim white. Comp F, open curly braces, inside colon, color 0,0,0, X, full stop. Then add the pipe character, and on a new line type border, colon, color 1,1,1, X, full stop, and close the curly braces. Then direct both door and window to this new rule. So next to the window rule, type trim, and next to the door rule, replace the color with trim. Save and generate to see the trim. Next, we need to make a bug fix for a bad window condition. Zoom out or explore the scene to find a building with a short wall, like this one here. To fix this, go to the window wall rule where the shape is sent to window pattern. Change it so that the code only executes when the wall is big enough to have windows. Right before the existing code, make a case statement where we'll use scope to specify a minimum wall size. Type case scope.sx greater than 2, colon, then give it an else case, else final shape called X. Save and generate, and the windows on the narrow wall should disappear. Now zoom out some and select a smaller cluster of buildings and generate. Looking at the buildings, do you notice something we can change to make the neighborhood more realistic? Maybe we could randomize the heights and floor counts since these are all 3 stories tall. Scroll up to those attributes and change them to use random values within their range. Change the default value of floor count to a random number in our range from 1 to 3. Replace the 3 with rand, open parentheses 1, 3, close parentheses. This rand function will give a random decimal number within the specified range, inclusive of the endpoints, but we need a whole number or integer for the floor count. So we'll use the rint function, spelled R-I-N-T, which rounds to the nearest integer. Insert the rint function so that the rand function is applied as the input parameter to the rint function. Change the code by adding rint around rand. Now floor count will either be 1, 2, or 3. Do the same for the floor height attribute, but we don't need a whole number, so skip the int. Save and generate. There is now a more realistic city with variation of heights and floor counts. There is now only one more change to the rule. To make our city model smart, it needs to tell us something of value. So how about the total floor area of every building in the scene? Go to the Extrude Mass rule and add a report to this model. Before the first line of the rule, insert this. Type report, open parentheses, double quotes, gross floor area, double quotes, comma, floor count, asterisk, geometry dot area, close parentheses. The report operation attaches numeric data to the model, which is summarized in the Reports tab in the inspector. Save and generate just one building. Open the Reports tab. You'll see several columns, the first being the number of shapes reporting this value 1. Then you'll see the sum, average, and min and max of the gross floor area of that model. Now experiment for yourself and select several buildings at once and generate them to see the reports for those models. To see the fruits of your labor, save the rule and the scene, and then zoom out and generate the entire city. You've now reached the end of CGA Tutorial 3. The rules you've built demonstrate most of the basic concepts of CGA.